Now that we've talked about what similar figures are, we're going to talk about 3 different ways on how we can determine if two triangles are similar to each other. And that would be, we have AA, so angle, angle, side, 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 and side, angle, side. So side, angle, side, and side, side, side are not exactly the same as congruent triangles. We are going to do something different with those, but we're still lining up our corresponding sides and angles together. So similar figures need to make sure that we have congruent angles and proportional sides. And we can prove that they are similar using a side, 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 and side, angle, side similarity postulates. So the symbol for similar is going to be one little squiggle instead of our equal sign with a squiggle above it. And AA for the similarity postulate is if we have two angles of one triangle that are congruent to two angles of another triangle, then the two triangles are similar. The way that we can write that for a similarity statement is our triangle JKL is similar to triangle XYZ. And just like we dealt with our congruent triangles, we have to make sure that the corresponding angles and sides are lined up together when we write our similarity statement. So for number 1, we need to determine if the triangles are similar, and if they are, we need to write the similarity statement and explain our reasoning why. So first off, we need to find out what those missing angles are going to be. So if we take 180 and subtract our 90 and the 26, then this little angle comes out at 64 degrees. If we do the same thing for the triangle on the right and take 180 minus 64 minus the 90, we get a 26 degrees. So we can see that we have different angles that are congruent to each other. We actually have 3 angles that are congruent to each other, but we have at least 2 angles. So yes, these two triangles are similar by angle, angle. When we write the similarity statement, we have to line up the angles together. C is congruent to K, and D is congruent to G, and then H would be our last one in there. And number 2, whenever you see two triangles overlapping like this, you really want to draw them out separately. And once we realize that, we have our 52 degrees is congruent to our 52 degrees. Because the angles are sharing that angle A up there, we know that angle A, whatever it is going to be the same for both. So we can see that we do have 2 angles that are congruent. I would like you now to fill in the similarity statement. If I set it up as A, B, E for the first triangle, I want you to set up what the similarity statement is going to be for the second triangle. What you should have set up then was A, C, D. Number 3, we can see that we have vertical angles in the middle. And we will also have these alternate interior angles that will be congruent because of the parallel lines. And because of this, we do have that the two triangles are similar. And they are SVR, so then I need to set them up the same way. So S and V lines up with U and V, and then ends up at the T. So it'd be U, V, T. The second similarity theorem is side, 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 and that's if we have all 3 side lengths of 2 triangles are proportional to each other, then the 2 triangles are similar. So if we line up the different sides together and they are all the same ratio, then that shows that this is side, side, side. So in number 4, that's what we need to do. So we're going to line up all the different corresponding sides. Remember, to set up a proportion to solve for the x value, we need a side that has just numbers. So that would be our 4 and our 12 are just numbers. Then if I want to use the purple pieces, I would have x minus 1 over the 18. And now we can solve for x. And it doesn't matter if I use this one or if you use the one in pink. It doesn't make a difference because it should be the same ratio. So if we cross multiply, I want you now to finish it up and tell me what the x value is going to be. You should have gotten 72 equals 12x minus 12. When you add the 12 over to the other side, you would get 84 equals 12x. So x equals 7. And if you wanted to, you could plug it back in and find out what the lengths of those sides are going to be, but that's not what this question is asking. It does ask, though, for the scale factor. So if we go left over the right, that would be our 4 over our 12, and we could reduce that down to just a 1/3 for that scale factor. For the last similarity theorem of reasons why we can prove that two triangles are similar is side angle side. So if an included angle of one triangle is congruent, because remember angles are congruent, to an included angle of a second triangle, and the side lengths surrounding the angles are proportional, then the triangles are similar to each other. So if you notice that this angle X and angle M are the included angles because the sides that are surrounding them, so these sides surrounding them, are proportional to each other. And because those angles are congruent and the sides proportional, then we've got side angle side of why those two triangles are similar to each other. In number 5, when we're pairing up to see if the two triangles are similar, we have to check to see what angles we have that are congruent. And we do have one pair of angles that are congruent in this picture. And we have two sets of sides that could be proportional. So what we need to do is find the ratio of, I'm going to do left over right again, and we want to compare what those ratios are of this pink and the blue sides to see if they are proportional. So if they are proportional, then that tells us that this triangle could be similar to each other. And when I reduce 6 over 9, that becomes 2/3. And when we reduce 10 over 15, it also becomes 2/3. That tells us that our sides are proportional. When we fill in the similarity statement, then we have that if we set up the first one as GFH, remember the first one doesn't really make a difference of how you set it up, it's the second one that has to be the same. So then it would have to be BAC, so that it ends up going in the same order. Now the scale factor between these two triangles would be the 2/3. And some of the times you will be asked what the scale factor is going to be between the two triangles whenever we have them. So on to number 6, we have really 3 different questions. We want to determine if the two triangles are similar to each other, and now we've got 3 different ways in how we can do that. If they are similar, you need to write the similarity statement, just like we've been doing on all the other ones, and tell us the reason why. And then if there are sides to compare, I want you to write out what the scale factor is going to be. So on this first one, we need to figure out what all 3 missing angles are going to be first. When we do that, this first triangle is a 31, and the second triangle we have a 47. So we have one angle that's congruent, our 92, but that's all we have. Because that is all we have, that is not enough information to determine if they are similar, and we don't have 2 angles that will be congruent, so these are not similar triangles. So on to this upper right one. We do have vertical angles again, so we have one set of angles that are going to be congruent. And when we are pairing up the sides, what you want to do is notice this 9 is smaller than the 18, so most likely it's going to pair up with our 15 since that is smaller than the 30. So then we want to check the 18 against the 30 and see if that ratio is the same as well. When we reduce the 9 over 15, we get a 3 out of 5. When we reduce the 18 over 30, we also get 3 out of 5, so the sides are proportional. And as you can see, we have the included angle is the one that is congruent, so yes, these two triangles are similar. So if I set up the first one as A, B, C, the other one needs to be set up the same way. So I know that my C is going to be the last place, and my pink needs to be the last side. So to go backwards, I need to start at D, E, and then C. Just like I did on the other one, if you have 2 overlapping triangles, you want to separate them out, and you do have plenty of space on your notes paper. So TQ, this furthest side, we would have to add the 2 pieces together, and that would give us 13.5. For SQ, we have to add 7 and 14 together, and we get a 21. So that gives us the remaining sides in our 2 separate triangles. One thing that's really nice to do is if you set it up with color coding to make it a little bit easier to follow. So we just need to check to see if the sides are all proportional. So we're checking basically to see if this is side, side, side. So if I do the left over the right, so I'd have 15 over 10, we have 13.5 over 9, and then we have a 21 over 14. We need to check to see if they are all the same. So if I divide 15 by 10, I get a 1.5, or I could write it as 3/2, your choice. For 13.5 over 9, I also get 1.5, so far so good. But remember, all 3 sides need to be proportional, so don't jump ahead and say that they are unless you check all of them. 21 divided by 14, we can divide each of those by 7, and we also get 3 halves, or 1.5. So all three sides are proportional. So when we're filling out our triangle similarity statement, if I go STQ, so in that order, then I would have to do RUQ as well. Okay, so I want you now to fill in what is the scale factor and do left over the right. So fill in what is the scale factor between those sides. Since that's how we set up our ratios over here, if we reduce it, it just became 3 out of 2.